Welcome, everyone. Thank you for coming to the Microservices 101 for the Cloud Advantage Summit that we're having here. Um, we'll be covering microservices, what they are, traditional architecture, benefits, how US supports our clients, that type of stuff along the way. But first off, I'd like to introduce myself. I'm going to be the primary speaker. My name is Stephen Webb. I'm a solution architect for US Signal. I've got 20 years of experience helping clients with their IT infrastructure needs. I'm joined by my friend and coworker, Matt. Do you want to introduce yourself?
Yeah, thank you, Stephen. Hi, everyone. My name is Matt Urbanowitz. I'm the manager of hosting architecture here at US Signal, 13 years with the company. I've been in IT services for about 28 years or IT generally for about 28 years and IT services, be it resale, hosting, consulting, solution architecture for about 20 of those years. I'm based out of Minnesota and glad to be with you today.
Thanks, Matt. Um, so this is our general agenda for the day. You're going to be spending the next about 30 minutes with us. I'm going to try to leave about 5 minutes for questions at the end. So feel free to drop any questions uh, during the session, and we'll try to get to answering them at the end. Uh, so let's jump into it. So what are microservices? Microservices, I always like to just start with definitions when I start these type of talks because not everyone understands what microservices are. So microservices are small independent services that really work as a unit to form an overall application. Some key traits of a microservice is really that they can be scaled, deployed independently, and every different service can also utilize a different tech stack. So Matt, if you think about uh, like Python's really good at at business intelligence and numbers, right? Versus like a Ruby on Rails or a PHP is better for like a web architecture type thing. So you can use different tech stacks. One of the other unique features of a service is they tend to most all the time manage their own data or their data set. So think about a service being tied directly to a database. One example of that is like a retail application. A retail application with microservices may be made up of several services, like one handling the user accounts, one handling the shopping cart, one handling the product catalog. But, when you go to like check out your shopping cart, it might need an address. Well, instead of itself dipping into the database directly, it's going to go over and ask the user accounts service just for, hey, what's that user's address, right? And then it's going to use that as part of the checkout process. On the other hand, if the checkout process doesn't need to know the existing user's address because they're not shipping it to themselves, they're shipping it as a gift, you may not even go over to the user account service. Does that make sense, Matt?
It does. Yeah. It seems much more application focused versus role focused. Would that be safe to say?
Correct. I look at it more of function based, right? So
Function based thinking, yes.
you're gonna make a service that has a specific function for the overall application, right? So you're not trying to build an application in a single service, right? That by its definition would be not a microservice because you're building the entire application, right? But it's just
Yes.
handling one particular function, right? The key to microservices is you're trying to break down the complexity of the overall application into like distinct units that can work somewhat independently of each other.
Make the elephant easier to eat.
Yeah, exactly. So because if you've got an element, it's pretty hard to swallow, right? Uh,
One
and
bite at a time.
and I always get, whenever I do a lot of these projects, I always get locked up in like analysis paralysis, and that's what can happen in like some of the more traditional things is you analyze how is the best way to build this because I'm trying to build it all in one thing, and you're trying to eat the elephant, right? And so
Yeah.
the application never gets off the feet. But if you use microservices and you're only focused in on, you got your blinders on and you're only focused in on just how am I taking care of my user accounts? That's an easy thing to solve, right?
That specific function within the broader application.
Correct. Correct. Absolutely.
I like it.
All right. Now that we've started with a definition, let's talk about, well, what else is out there? How else do you do this? Well, uh, a lot of people in the industry have called it traditional. I like to use, monolithic because again, you're building all of your functionality into one monolithic code base and one database, right? So when you choose, hey, I'm going to write it in Ruby on Rails, you're writing your entire application using that software package, right? And can be
Yeah.
challenges because not all uh, not all technology is software technology is best for all things, right?
Hmm.
Um, but you know what? I really like to look at uh, traditional versus microservices using different diagrams than what I have on the page here. So on the page here, I've got an example of 4 different monolithic architectures, kind of very common ones. And on the right-hand side, I've got a diagram of a very typical microservices architecture. However, like I said, I don't like to look at it this way. I like to look at it as like pets versus cattle, right? Right. So Matt, what are pets?
Pets are companion animals that
Right.
we bring into our homes and adopt and treat like family members.
Right. So they are unique. You're going to have your cat or your dog or your bird and it's unique. And especially like dogs, you're going to train and nurture that dog to be that companion for you, right?
Hmm.
Versus a farmer with cattle, right? So cattle typically, what do they have on their ears?
A tag,
A tag, a
an
number.
asset tag.
Yeah, an asset tag. It's a number. It's money to them, right? They also have like cattle have like a predetermined life cycle, right?
Yes.
A lot of times cattle is interchangeable to the farmer. So he looks at a cattle as well. That's beef and that's beef, right? Um,
Yeah, we refer to them as a head of cattle. We don't name our livestock.
Right, exactly. They're not unique. What I'm saying? Now, I will say, like, if you look at a dairy farm and you look over the dairy farm, the cattle might have different spots, right? AK like different services. So, anyways, in microservices, right, cattle aligns with scalability. Stateless services can be replaced, replicated, uh, resilient, flexible, because the cows are interchangeable. They're typically labeled with a number that, hey, service 123 went offline. Oh well, we'll get service 123 back online so we have uh, the scalability we need for the application.
Cattle have a purpose. It's an important purpose. They have a role to
Absolutely.
play, but we do not develop relationships with them. We do
Correct.
not
Now,
develop dependencies upon them. They are, as you said, replaceable.
right. So with that, you start thinking of cattle as more like dynamic, probably better suited for a cloud native environment over a pet, right? Which are less suited for distributed because, well, your pet's unique.
It
My
is.
dog's Hershey, right? Hershey's unique. I can't replicate or duplicate Hershey very easily because it's unique, right? Um,
Yes.
so this is the way I like to look at microservices versus monolithic. You've got the really
Yeah.
unique nature of pets versus the semi unique but easily replicatable of a cattle herd, right? Does that help you, Matt, understand what traditional versus microservice architectures are?
Yeah, I think it does. To me, it's saying, all right, the traditional application hosting in the monolithic way is very tailored, and you're going to
Hmm.
see a lot of, shall we say, personality amongst the different
Absolutely.
elements within it, a lot of customization, and those elements are not going to be very easily replaceable. And so
Not
I'm
easily, but and it's very hard to scale. Especially when you're thinking about I've got
yes.
this one massive database and a monolithic application tied to this one massive code base. Well, how do I get it to work in multiple data centers? How do I get it to scale out when I have that retail application that gets hit by Black Friday, right? Since it's
Hmm.
very unique, there's a lot of work into making that very unique application now, have two databases now, right? Because it's all in one versus microservices, you can scale a
Yeah,
lot easier.
it seems to me like this example would also say if an element within a microservices application hosting environment fails, it's like, okay, well, that's unfortunate. There may be some cost associated to it, but there's not a lot of customization. There's not a lot of, shall we say, emotional attachment. We can replace it very quickly.
Absolutely. Again, going back to the tag number on the ear of the cattle, it's 1, 2, 3.
Mhm.
It's not Hershey, right? It's not unique. It's just 1, 2, 3. Yeah, we've got to refer to that. But yes, you're absolutely right. The other thing it does is since from a cattle perspective, how easy is it to yeah, you know, from a life cycle perspective, how easy it is to take a herd to slaughter, right?
Right.
And refresh the herd, right? So if there's anything from a perspective, you can sell off some of the herd and you can add more, right? Anyway,
Yes.
this is just a way that I think about it being the unique nature versus not. I don't know. To me, it resonates a little bit better.
Okay.
So, okay, now that we've talked about traditional versus microservices, um, why do microservices matter, right? I, I think you've probably grasped on to some of it, right? Is that if you look at the right hand side of the slide that I have up, it's really all about scalability, agility, resilience, and flexibility that you gain by going down a microservices architecture, right? Um, it really makes that time to market faster because again, like I stated earlier, you can really focus in on that storing that user data and make those choices very easy, right, for that service, and then you can move on to shopping cart and other aspects of that example retail application, right? um,
Yeah.
and again, looking at that user thing, the agility. Hey, if I want to start adding another field of data to store for a user, I'm only affecting that user service when I want to add that. So again, that time to market's faster because I can add and iterate on the individual services, then looking at, oh, how is this one field that I'm adding to the database going to affect the overall application? Because again, different services or different functions of your application may need user information. Again, shopping cart into the user database to get your address, right?
Yes.
Again, you've decoupled those from the actual storage of the data to those API calls, or I really haven't covered it, but the message services, the service broker calls to return information to and share information between the services.
Got it. Stephen,
It's yeah,
looking at your bulleted list there,
mhm,
and maybe this isn't the right time for this question, but just let me know if we would
yep,
just want to kick it down a little further. I see cloud native apps and I see high traffic platforms for retail or finance. Um, I'll admit I have limited, this is why I'm attending your session. I have
yep,
limited knowledge and understanding of microservices.
right,
I've been working in this industry and again at US Signal for 13 years, but in my experience as a solution architect and then also leading the team, I see very little actual practical application or deployment of containers and microservices. But I think that's because anecdotally, my exposure has been more to hosting clients that are more what I'd characterize as cloud as back office, right? Like they're moving. We have municipalities and enterprise organizations where they're moving like dozens of applications to our hosting infrastructure, and I feel like maybe that cloud as back office category of hosting customer is not as likely to be a user of microservices as, say, a SaaS company or a
Correct.
company who's maybe got one or a handful of applications that are really the bread and butter of their company. Am I kind of on the right
Yeah,
track there?
uh, you're close. The way I look at this is there are a number of applications that you are using today that are using microservices, and you may not even know
Okay,
it, right? Because
sure.
a lot of the customers that um, are utilizing microservices today are the customers that have built their application from the ground up. A
Yes.
number of the customers that you and I and others at US Signal interact with, we interact with probably a higher number of customers that used packaged software, right?
Yes. Commercial
And
off the shelf stuff. Yes.
so I'll give you an example of one that you may not know is using microservices, right? But you have sold a number of them, Matt, and that
Okay.
is our Relia Cloud product, right?
Oh, yeah,
Did,
yeah.
did you know that Prism Central is built on top of a microservices architecture?
Oh, okay. No, I did not know that.
Okay, again, that's that packaged product that you're utilizing microservices, right?
Okay.
Another one that you've used is Netflix. Netflix is totally built on a microservices architecture, right?
I
So
watched the Netflix show yesterday.
exactly. So there's a number of people, a number of software companies out there that are building into utilizing microservices, right? And so as an IT industry, we've got to know about it, right? But you're not going to go out and buy software that is for, you're not going to buy software that you're going to deploy a container for. A lot of the container stuff is either you're going to build that container yourself from the ground up, right? Or you're going to leverage a number of the pre-built containers that are on the market and glue container one, container two, container three together into a microservices application, right? Probably with a little bit of glue code to glue those containers together um, to make them work. Does
Okay.
that help?
Yes, very much. Thank you.
And really from that high traffic platform application, again, going back to our cattle thing, is if we need more cattle on a field, we put more cattle on the field. Same thing.
It's really that simple. Yeah.
It's really that simple. I mean, we just, do our excuse me, I'm not a farmer, right? So I don't know exactly the entire process of growing a cattle, but you would just grow additional cattle and you'd put it on a field because you got grass there, right?
Yep. You
Same
have
thing with
places.
microservices. You would provision or spin up additional containers to handle scale, right? And again, since they're cattle, right, you can have more and more cattle to be able to support the load coming in.
Is there a horizontal versus vertical scaling conversation analogy to be had here? Like, is the legacy monolithic approach vertical, whereas you beef
Yeah.
up the server, you beef up the hardware in order to make your application handle more traffic or volume or whatever the case may be. Whereas if you have employed microservices, you're very much in a horizontal scaling posture.
Well, and it goes beyond just traditional horizontal scaling. So, vertical is add more CPU and memory to your machines running it, right?
Yeah.
So you're just making that one machine beefier, right? A horizontal is that you're just deploying more of those machines, right? The um, the challenge there is that, or not the challenge, I shouldn't say, the you can deploy additional services like in different regions and other things. So it goes beyond just that horizontal in a single data center. It goes horizontal across the world using cloud services, using other data centers. That's the beauty of
Ah,
microservices. It really
okay.
doesn't matter where you deploy things in appropriate microservice. Make sense?
Okay. Yes. Yes.
So we started down this path already, right, with some of the challenges that come with microservices, right? And it really, with any new architecture, there's some challenges, but there's also beautiful ways to overcome these challenges. So, um, you think about this. If I'm splitting up this application, you have some increased complexity, right? You're distributing the system. So if you do a worldwide scale of microservices across the world, it's distributed. How am I going to take care of all of this, right? Um, if you have multiple teams on a DevOps culture that is developing that shopping cart in one language and that user account management in a separate language, you got to coordinate those teams to make sure everything works well, right? And then the more complexity typically comes with security challenges, right? The beauty
Yes.
of microservices is, since it's been around a long time now, they've solved a lot of these issues. So uh, the solutions to a lot of these challenges are really coming down. We've spoken a lot about containers, a lot about the containers to be able to decrease that overhead um, of those individual functions, instead of spinning out a big server that's highly unique to these individual services. That containers tend to be small, consume small amounts of CPU and memory because it's doing that only that single function, right?
Hmm.
Um, with this, you add both CI/CD, continuous improvement, continuous deployment, right? Um, Couple that with some orchestration, something along the lines of like Kubernetes, to be able to help you scale, right? And then the last piece is really just to monitor your whole thing. So there's tools out there like Prometheus and Grafana to track performance over time and how many requests are coming in, right? So there's all these tools out there to really take some of that complexity and reduce it to a manageable scale. And again, instead of trying to patch those very unique individual applications and servers out there that have a high risk of things going down, you're redeploying brand new every time with new software updates with containers, right? It's typically not updating. The containers a lot of times are a you build it once and you deploy it many times, right? The same container, right? So it's not like you're going and doing your Windows patching on a dozen servers that are supporting an application.
Okay. And container, would it be safe to say containers are small, kind of lightweight from a resource utilization perspective,
Absolutely.
very, very specialized, very dialed into their role within the application stack and good at it.
Eh,
They're very tuned and optimized for their specific role.
yeah, absolutely. I mean, a lot of the extra cruff has been removed from those containers, so it is just very succinct what its use is.
Okay.
So, U.S. Signal's approach to this, right? Uh, Infrastructure is what we do best, right? So we are not necessarily today a software development house to develop your application for you. But
Hmm.
once you have that application developed, or even in the process of being developed, we have a number of different things that we can do to help support that application and scale that application, right? Most microservices applications have been have gravitated towards Kubernetes. Kubernetes was originally built by Google, right, for a lot of the original Google services and the original Google search engine to do the massive amount of work that Google does. So, but Google took Kubernetes and kind of gave it to the IT industry to grow and change and morph. And Kubernetes is better than that original project that Google released years ago, right? So a number of our products out there support uh, the ability to run Kubernetes. So you see three of them on the slide. Our OpenCloud, right? Totally can support containers and Kubernetes to be deployed within that.
Okay.
ReliCloud's built on top of Nutanix. Well, I already mentioned that ReliCloud is already leveraging microservices for its own internal use for Prism Central and Prism Elements to do a lot of the management of, a Nutanix cluster, right? And then Azure is out there for that scale beyond the wall. So if you're doing a worldwide approach and you need to run some containers in India or China or Russia, Microsoft has that reach to be able to scale out that. And, hybrid approaches work really well. If you want, your core data for most of your services in OpenCloud, but you want a little bit of data in the edge near your customers, again, you can mix OpenCloud and Azure or OpenCloud and ReliCloud, because
Yes.
again, your focus is on that CI/CD pipeline and containers that you're deploying, not necessarily these hard, unique servers of the past to be able to move around and deploy.
The ReliCloud example, I think Nutanix has even sort of trademarked it, NKP, Nutanix Kubernetes Platform. Is there,
Absolutely.
okay, is there a variation on it?
And there's different things, and I don't want to get too technical or too deep here, but
Thank you.
there are various things to support Kubernetes well. One of them is you still have to store data, right? And if you have containers that you've built once and deployed many, well, how are we storing data? Because we don't necessarily want to store the data in the container because now it's unique, right? So the storage of data, there's different plugins, and like with ReliCloud, the plugin is there is a Kubernetes plugin to ReliCloud to use the ReliCloud storage, right? Um,
Okay.
there's other things that it's very common for in a microservices architecture just deploy a base set of, I call them throwaway VMs because they can be easily replaced, right? A base set of VMs on top of any type of virtualization architecture. So, they're, like example of Azure. Azure has native Kubernetes support as a platform as a service. But there are a number of people out there because they want to control some of the functionality at an infrastructure layer a little bit more than what Azure is deploying, that they come back and they install something like K3S or which is a Kubernetes distribution, or
Mhm.
RKE2 or Rancher government distribution of Kubernetes just within VMs, right?
Okay.
So you're still getting the full power of Kubernetes, but again, you're supporting it at a VM level. And again, that's to control the feature sets of, the CI/CD pipeline in Kubernetes,
Got it.
right? So talked a lot about microservices and how US Signal can help. So if you had an application in mind that you really wanted to get started with microservices, this resonates with you, that hey, this sounds like a really good approach. Well, I'll leave you with this, right? There's kind of three major pillars of getting started in microservices. First, you got to determine if microservices is a fit. It fits for a lot of application, but maybe not all, right? And
Mhm.
it also depends on how much you have invested into your traditional architecture and how well your architecture works. I'm not for changing things that aren't broke, right? But if you do have scaling issues, if you do have patching issues, if you do have a lot of those things, microservices could be a good fit, right?
Okay.
Once you've made that choice, then you got to start breaking your application down into those individual services. How can I do this, right? Implement and scale.
Fantastic.
Um, and I'll just leave you this slide. Again, microservices helps with scalability, agility, resilience, flexibility. Um, Yeah, and we're here to help. So come talk to us, and we'll help you figure out if microservices is a good fit.
Thank you, Stephen. I know more
Yep,
than I did 30 minutes ago.
30 minutes ago. Um, drop the questions if you do. We'll try to get them answered. We're kind of running short on time. I got a little long-winded, but we'll try to get the answers out to you. Um, if you attend 3 sessions over the next 2 days, you can be entered to win some cool stuff. Um, Here in a few minutes, the next presentation will start with Taylor and follow up with a Q&A. Thanks everyone for joining.
Thanks, Stephen.